This is the last video of this section, using native HTTPS client libraries. In the previous video, we have created Web Broker Apache modules. In this video, we will learn cross-platform HTTPS client. The RTL provides two components that you can use to send HTTP requests to servers and handle their responses. TNet HTTP client, TNet HTTP request. Alternatively, as we saw in Part 1, Knowing Your Friends, the Delphi RTL, you can use an instance of THTTP client to manage your HTTP requests. Why use these components instead of good old TID HTTP from the Indy suite? The reasons have been explained in Part 1, Knowing Your Friends, the Delphi RTL. However, in this video, we'll use the new HTTP client to show how much the deployment is simplified, also in mobile apps, using these new components instead of the Indy ones, at least for HTTP communications. Long story short, Embarcadero developed a native HTTP client library that is not based on Indy nor OpenSSL, but then relies on the OS API to implement HTTP protocol. So when Microsoft, Apple, or Google release a new security patch, your application is already updated. Great! You simply rely on the OS security infrastructure and don't depend anymore on the OpenSSL DLLs. In this video, we'll see a simple but complete cross-platform HTTPS client able to connect to these two functions. An HTTPS service using a valid certificate provided by a certification authority. An HTTPS service which uses a self-signed certificate. The TNet HTTP client component does a great job of integrating with the underlying OS to provide a uniform development and deployment experience to the Delphi developer. This project reuses the unit async task.pas developed in Using Tasks to Make Your Customer Happy, the 1,000 faces of multi-threading. Let's see how it works. Open the project in xplat native http client.dproj. The main form is similar to this. The two upper buttons send a request to the Apache HTTPS service developed in the previous video, when the third button sends a GET request to the GitHub API to get information about the username written in the edit, while the GitHub HTTPS contains a valid certificate provided by a recognized certification authority. The local service uses a self-signed certificate. All the HTTPS requests are executed by a data module which contains an instance of TNet HTTP client. Let's check out the THTTPA data module. This data module contains all the methods used by the main form to do the actual HTTPS requests, plus some other helpers required to make asynchronous requests a bit simpler. Here's the code. This code is a nested type used as a value data object to return response data from the data module to the main form. This line of code will just forward the request to the TNet HTTP client. As soon as the data are being read, we count it to inform the main form about the total bytes read with this line. This method is executed only in case of self-signed certificates, and in this code, a self-signed certificate is always accepted if it is not expired. F-certificate contains the last self-signed certificate accepted or is empty in case of valid certificates. This will just forward the request to the TNet HTTP client. This insert works like an append here. This code is quite simple and is just a high-level wrapper for TNet HTTP client. How does the main form use this? Let's check out the main form code. Quite a lot of code, but the things to understand are few. This will replace the IP with your actual address. This will also replace the IP with your actual address. The most important is the wrapping of the TNet HTTP client inside the data module. The THTTP DM could also be more specialized with specific methods that completely hide the internals of the system, but in this case, our objective is not this. Please don't use the btn post-click event handler. Also, if it's not really needed here, I'm using it to show how to generate JSON text using the tJSON builder object to achieve a small memory requirement, especially useful on mobile, but also in servers and in general when your JSON may be big. Now, try to run this project on Windows. Did it work? Try to click on the buttons and check the certificate information returned for a self-signed certificate, the one from our server, and for a proper certificate, the one from GitHub. Now, select Android or iOS as target platform and try to run the project as a mobile app. As shown here, remember to change the hard-coded IP address to yours. As you can see, it simply works. You don't need to deploy OpenSSL DLL or object code, like it was usual to do with Indy. Moreover, I quite love this integration between the OS HTTP layer and mine. It makes a lot of things simpler and is completely cross-platform. The TNet HTTP components are a must if you want to build HTTP-enabled applications, especially on mobile, so you have to know them. Play with them. Use them. If you have HTTP-enabled apps using Indy, consider switching to TNet HTTP client. You will simplify deployment and development and take advantage of the deeper integration with the OS. Here's a well-written document about the TNet HTTP components directly from Embarcadero Wikidoc. This link is for using an HTTP client. Great! We've successfully learned how to use native HTTPS client libraries. This video concludes the last video of this section. In this section, we've learned how to implement a RESTful interface using Web Broker, and then we've seen how to control remote application using UDP. After that, we learned how to use app tethering to create a companion app. Also, we've created a DataSnap Apache modules and Web Broker Apache modules. In the last video, we've learned how to use native HTTPS client libraries. In the next section, we'll learn about Mobile Revolution with FireMonkey.